Hi everyone, we're going to establish trig identities by factoring. It's a little more complicated. Since this side is more basic than the left side, we're going to go ahead and there's two different ways you can do this. There's one way that the students like that you could just rewrite this as sine squared of theta plus 3 cosine squared of theta, because there's 4 of them, plus cosine squared of theta, and then factor out of 3 for this group right in here, and you get 3 sine squared of theta plus cosine squared of theta plus cosine squared of theta. Now we know that this equals 1, so I just changed that to 1. You get 3 times 1 is 3 plus cosine squared of theta, and that's what we wanted. Or you could have written this as 1 minus cosine squared of theta from your Pythagorean identities. Now you distribute, you get 3 minus 3 cosine squared of theta plus 4 cosine squared of theta. Now this here is negative 3 of these plus 4 of those is one of those. You get 3 plus cosine squared of theta, which equals what we want. So there's 2 ways to do that. Okay, the next one is the same way. I'm going to go ahead and write this as secant squared. Let's see what we can do. Let's just write it like we did the first way. So for this 9, we're going to write, because we have a 5 here, 4 secant squared theta plus 5 secant squared theta minus 5 tan squared of theta. Now I'm going to take these two and factor out the 5. So you get 4 secant squared theta plus 5 times secant squared theta minus sine squared of theta. Now we know that this equals 1. So we get 4 secant squared theta plus 5. Or you could have done it the other way. I did it and get the same results. And of course you can rearrange all this. So okay, the next set looks a little complicated, but it's not really. If you know that cosine squared of theta, and I'm just going to keep the 1 out here for a while, is really, and don't forget we're subtracting this whole thing, is 1 minus sine squared of theta. Now, I'm going to use the fact that this is a squared minus b squared equals a minus b times a plus b. So we have 1 minus, and I'm going to write this 1 minus sine of theta times 1 plus sine of theta over 1 plus sine theta. This is not a square. Alright. Now what you notice is that these two will cancel. So we have 1 minus sine of theta. And when you distribute this, you get 1 minus 1 plus sine of theta. Well, 1 minus 1 is just 0, and you're left with sine of theta, which equals our desired result, sine of theta. The last one is the same thing, so I'm just going to write this and write this as 1 minus cosine squared of theta over 1 minus cosine of theta. And this is our desired result. I'm going to use my factoring, the difference of squares. It has to be 1 minus cosine of theta times 1 plus cosine of theta over 1 minus cosine of theta. Now these two cancel, and I'll do that. So you have 1 minus 1 plus cosine of theta. So if you distribute the negative here, you get 1 minus 1 minus cosine of theta. This is 0, so we're left with negative cosine of theta equals negative cosine of theta. Okay, that's all. The next video is going to be about how to establish identities by dividing. Thank you and have a nice day. Bye-bye.